This one we talk about is the total response of the damped systems under excitations. Okay, so basically that is the whole thing we considered. And here we want to consider the total response, and that means we must consider the steady state response in addition to the transient response. And in the last 2 lecture hours, we've been focusing on the XP. That means we've been focusing on this one. In particular, we spent quite a bit of time to exercise the amplitude of the steady state response. And again, from this amplitude, we derive the multiplication factors, and then we also went over the curve, the characteristic curve, and with a few examples about this term. Okay. And to include the transient response, and we take up this form. And this form, nothing special. This is simply what we've been exercising in the previous chapters. Okay, so that is being familiar with. So we added up the 2 things together. Okay, so basically we added up the 2 forms together, put into here. So in total, right now we look at the adding the 2 terms together. Let's look at how many unknowns we need to decide. Okay, the first one, we're looking at the transient response, and which is expressed in this form. And in this form, right now we can see the x knob is the amplitude of the transient response. And from the previous chapters, we know this one determined by the initial conditions. And zeta, omega n, omega d, those are the system-dependent quantities. So they are certain constants. This is the phase angle. Again, so in here, in this term, we only have 2 unknowns. And that can be determined by initial conditions. And we look at the steady state response. Steady state response, again, if you try to recall our lectures, the capital X and the phi, basically they are determined by R, right? And the zeta. So basically the 2 terms, if you look into your lecture notes, the 2 terms has been determined once we have all the information here. So in total, in this total response, how many unknowns? We only have 2. And that 2 actually is here and this one. So plug in the initial conditions in theory, 2 initial conditions, and in theory we can solve for 2 unknowns in the total response. And here I simply copy and paste of the expressions for the 2 unknowns like this. Don't take it as a formula, no. Okay, so wherever needed, we simply crunch the numbers, but this one is only for your reference. Even if you try to plug in all the necessary numbers into here, that would take longer time than you start from over to crunch the numbers for the things. So I wouldn't recommend, but here just provided for your reference. So in this way, our exercise, in my opinion, I won't put too much emphasis on the total response because here the focus is still on the steady state response here. But here we still have a probability of dealing with this one. So I just put this single slide without any example, just for reference. Okay. So good.
Okay.